So we are continuing our second part of Birch reduction. So in this class we will see some reduction of aromatic rings like benzaldehyde, aniline. So you can see it also reduced the aromatic rings. So this is the compound means benzene I have already discussed with you. It convert this benzene into two isolated double bond. So in these two compound you can see the position of double bonds are different. Means you can see here, if we consider the one, this is two, here the two double bonds are in 1 2 position, but here you can see in case of aniline means electron donating group, here is electron withdrawing group. So you can see is one double bond is in one position, another is third position with respect to this group. So why this double bonds position are vary with vary of starting material, we will get this point through mechanism. So this is the mechanism of reduction of benzene that I have already discussed with you. So simply what happened, the metal sodium simply gives electron, and in the presence of this electron, one of the double bond of the benzene simply homolytically cleaved. Then what happened, this electron comes and makes anion with paired up with one of the electrons. Here you can see, here what happened, this electron came and the electron comes from metal, simply paired up, simply makes it anion. Again you can see here is radical. So here is radical formed, but the thing is that there is repulsion between these electrons. What happened, they want to occupy far away to each other. So what happened, this electron pairs means forms a double bond with when this double bond cleaved. So simply you can see here, finally here is radicalized form, they becomes in 1/4 position. So you can see they becomes in 1/4 position. But the thing is that if we consider the product, you can see simply this anion can take proton, simply makes this type of molecule. Again this radical takes another electron and simply makes anion. Finally it converts this type of product. But in the reaction this protein is not formed. Why? Because there is repulsion between these electrons. That's why they want to exist in far away, means they want to stay in far away. That's why they exist in this form. So what happened, this anion takes one of the proton from simply NH3 molecule and converts this type of radical. Again this radical takes another electron from metal and simply makes it anion. Again this anion takes one of the proton from NH3 molecule and simply gives this type of isolated double bond product. You can see here in this intermediate means anion radical. Again I am writing this thing. Here I have just written in simply replacing the H by simply any electron withdrawing group. You can see the anion here is stabilized by electron withdrawing group. That's why the anion can stay here, means the anion will stabilize by electron withdrawing group. So what happened, in case of any electron withdrawing group, this intermediate means this intermediate is preferred. This is not intermediate, this type of species in formed in intermediate stage. So this anion is stabilized by any electron withdrawing group. So what happened, this anion takes proton and simply converts to radical. Again this radical takes electron from the metal and makes it anion, and again this anion takes proton from NH3 molecule and simply converts to this type of product means this type of double bond, two double bonds product. Here you can see two double bonds are two positions means with respect to electron withdrawing group. So what happened in case of some, if we consider some rings like CHO, you know that this is electron withdrawing group. So it simply reduced this ring to this type of product. So simply it reduced to this type of product. So the double bonds becomes in two positions means with respect to their two positions. You can see, if we can take more example, like you can take any two group. It simply reduce this compound in like that. So the double bond positions with respect to electron withdrawing group becomes in 1-2 position. But when this group means this group becomes electron donating group, in this case I have considered electron withdrawing group. But when the group becomes electron donating group, the product of the reaction becomes different. So you can see here, if we consider this group becomes electron donating group, the product becomes means two double bonds are in the ring, but the position are in different position. So you can see here one double bond is one position, another double bond is 3 position with respect to this group. Why this type of product is formed? In case of simply in electron withdrawing group, it becomes 2 position means two double bonds position are 2 position. But when this group becomes electron donating group, the double bonds become in 1/3 position. So we'll get this point through the species that is formed. Okay. We have already seen that before that in case of benzene, simply this type of species formed means this type of species is formed. What happened? This is electron donating group. So here you can see this anion. So there is repulsion taking place between this electron withdrawing group and negative charge in carbon atom. So this species is not stable. What happened? This species means this electron came here and simply this double bonds came here. Again you can see they are becomes more closer. That's why also here this space is also not stable. What happened? Is paired up, it means it makes double bond here by breaking up this bond homolytically. You can see here there becomes more stable. Here is electron donating group. There is here you can see repulsion taking place, but here is you can see there is no repulsion, and they are in far away to each other. What happened? This species takes means this negative charge takes proton from one of the NH3 molecule. Simply it converts this type of species. Again this species means this radical takes another electron and converts to anion, and finally it takes proton one of the NH3 molecule. Simply it gives this type of product. So whatever the electron donating group possible, let's see. You can see phenylalanine 1 is possible. Also phenol is possible. So simply it reduced this group and making this type of product, means the double bond becomes in 1,3 position with respect to electron donating group. You can see again, this is also, you can see here, this is also electron donating group. So similarly it gives 1,3 position of double bond products. So this is the, means these are the some examples of Birch reduction in aromatic rings. Again we can take some more example, like you can see here. What happened? You can see this is the electron donating group. So the means, so the group means, so the double bond becomes in 1,3 position. What happened? You can see the double bond becomes in 1/3 position. So these are some example of Birch reduction. You can take more example of it, depending upon your choice of electron donating and electron withdrawing group. Okay, thank you.